Hey there, hi everyone. So today we're going to be talking about the neuroembryology. It's an introductory lecture. We're not going to delve into any abnormalities. We're going to talk about the high yield basic embryology of the nervous system, or aka the neurulation. So I hope you guys have a good time and get something useful out of this lecture. So let's start. So first of all, when we are still an embryo, before we develop into, our full final version of ourselves with all those organs, we are basically a trilaminar disc, such as the one shown here in this diagram. And then this trilaminar disc gets folded that way and becomes this cylindrical tube, and then this tube provides us with all the parts of our body, such as the skin, the organs, all that stuff. So this disc here, this trilaminar disc, is composed of an outer surface called the ectoderm. The ectoderm provides us with the outer part of our body, such as the skin and the nervous system. And the part of the ectoderm that gives us the nervous system is called neuroectoderm, okay? Then the mesoderm provides us with the connective tissue of our body, of the bones, the muscles, the cartilage, all that stuff. And then the endoderm provides us with all of our internal organs, such as the liver, the gut, etc. All right. So during the third week, the neurulation starts and our body starts forming the nervous system. So we have something called a notochord. It's mesodermal in origin, and the part of the ectoderm that provides us with the nervous system, which is called the neuroectoderm, or another name, the neural plate. And during the third week, the notochord gives off a transcription factor that causes the neuroectoderm to undergo certain morphologic changes to develop into our mature nervous system. So, the sonic hedgehog transcription factor has a lot of other functions, including the separation of the cerebral hemispheres into right and left cerebral hemispheres. As we all know, our cerebral hemispheres are composed of a right and a left hemispheres, and all those little bulges here called the gyri, and all those little grooves here called the sulci, or the sulci. I don't know really. I don't know how they pronounce it, but I'm just going to call it sulci, okay? So, as we talked about, the notochord provides the sonic hedgehog transcription factor, and then this transcription factor acts on the neuroectoderm, and it causes neuroectoderm to cause this slight invagination that we see here, and a little bit of thickening like we see here. And so we end up with a neural groove here and two neural folds here. Then an extra invagination starts happening, and then the neural fold endings here form this crest called the neural crest, and then the invagination completes, and now we have a closed tube, and the neural crest separates like we see here. And then the neural tube provides us with a lot of things, and neural crest other things, and the notochord other things. So as for the neural tube, it provides us with the CNS neurons, the ependymal cells, oligodendrocytes, astrocytes, and those cells, we're going to be talking about them in other lectures. The neural crest basically provides the peripheral nervous system, and the Schwann cells, melanocytes, all those stuff. And we're going to be talking about that in later videos. So basically, the neural tube provides us with the CNS, and the neural crest provides us for the PNS, for the sake of the argument. And the notochord provides us with the nucleus pulposus. Okay, what is the nucleus pulposus? This is our spine, okay? These are the vertebrae. Between two vertebrae, we have the intervertebral disc. It provides us with flexibility and it reduces friction between the adjacent vertebrae. And it has a central part which is called the nucleus pulposus. It's basically a gelatinous part that's 90% water. And this part, provides the spinal cord with flexibility and mobility. And we have an outer fibrocartilaginous part called the annulus fibrosus. As we see here, the notochord provides us with this central part called the nucleus pulposus. Whenever you hear patients saying they had a disc herniation, what happens basically is this part right here, the nucleus pulposus, gets herniated out of the annulus fibrosus into the spinal canal and compresses the spinal cord over here. So, the notochord provides us with the nucleus pulposus. So now that we talked about the closure of the neural tube, we want to look at that neural tube from above and talk about how exactly does it close. Okay, so first of all, this is the neural tube. This is a Da Vinci quality drawing. I can already sense you guys saying that. So what happens first is this middle part here closes, like so. This happens in day 23. And then the upper part closes, and then the lower part closes. Okay, so when the central part closes at day 23, that leaves us with two openings, an anterior opening and a posterior opening. The anterior opening is called the anterior neuropore, or the cranial rostral neuropore, and the posterior opening is called the caudal or posterior neuropore. The anterior neuropore basically provides us with our brain, and the posterior neuropore basically provides us with the spine. If they close. If they don't close, they'll provide us with They will provide us with problems in the brain and problems in the spine. Okay? So first of all, day 23, closure of the mid portion of the neural fold. Then day 25, the anterior portion closes, and then day 27, everything closes. And by week 4, the whole neural tube should be closed. If this fails to happen, then we have something called the neural tube defect, which will be the topic of the next lectures. So I hope you had a good time. I hope you understood something from my ramblings in this lecture, and I'll see you in the next one.